Alright, so we're looking at problem number 1 here. Now, this problem, do you agree that these are different than the ones we did yesterday? Yeah, they are. They're different. It's not distributive. It's not commutative. It's not, that type of stuff. These are equations. So doing these problems take that 4-step process. If you didn't remember that step process we did the other day, so when you solve an equation, so we're solving equations. Notice I said solve, not simplify. So we're going to solve equations. The 4-step process we have, number 1, is that you're going to do a property of equality first. This one is the easiest one to figure out. It's because most people, when they first look at a problem, they're like, oh, I need to add. You just said the property name. I need to add. It's add property of equality. You got your stuff in there breathing. Yeah. I figured somebody left it here. I didn't know if it was from yesterday or... No. Okay, so property of equality. So if you had to add or you had to subtract or multiply or divide, first step, that's what you have to do. Again, you have to go through the property of equality. Second step is you have to look for one of your inverse properties. Your inverse. So that's where you would, so whatever problem they're doing, you have to look at the next step. It's probably either a property of opposites or it's going to be a reciprocal. Those are your 2 inverses. But it's based on what you did first. I can give you the hint today, whether you know it's going to be a property of opposite or inverse, guaranteed by looking at the problem. Okay? Number 3, the third rule, is you're going to do an identity. And again, the identity is, there's a shortcut to know which identity you should pick, because there's 2 identities. There's the additive or multiplicative. There's a shortcut for when you know if it's what inverse it is. It automatically points you the direction what identity you're using. And the last step number 4, you should be doing a substitution. So this is that worksheet 2.6 we've been working on all week. You should have that out. Okay, I'll give it a little bit of time. Hopefully everyone's got it. It's one we had Monday and we worked on it yesterday and all that good stuff. So, okay, everyone's got it, I think. Wheeler, make sure you have a worksheet 2.6 up.
I don't have one.
I do not have one.
I wasn't here yesterday.
Or Monday, or Tuesday, or Wednesday. That's not true. Because everyone got one. So now you gotta do the top 3 by yourself.
That's fine.
Now, let's go through the steps. So problem number 1, okay? When you look at this problem, you have to do the inverse operations, right? I know our first property was going to be a property of equality, but we have to think about, okay, we have to do opposites on equations. It's not PEMDAS anymore, it's SADMAP. What do I have to do first? Get rid of the 8 so the x is by itself. Subtract 8. All right. The simple fact that you said we had to subtract 8, you already listed the first property. You had to subtract, right? So, what do you think you put after the word subtract?
Property.
There you go. So, the first step, you subtracted 8 to both sides. That's subtraction, property of equality. This is subtraction, property of equality. Easiest thing in the world. Okay, now that you've subtracted to both sides, now we have to do the one side by itself. So we've already figured out this one. So now, this is that little hint that I told you earlier. When you already pick your property of equality, so if you add or subtract, first, like what I did, this automatically leads you to one specific inverse. There's 2 inverses. The inverses that you have. There's the property of opposites. Or there's the reciprocal property. Well, I wrote these in a very specific way. My next property, if I did add or subtract, it funnels you to this one automatically. The property of opposites is when you add or subtract numbers and they make 0. What's 8 plus negative 8?
0.
0. I knew which one it was going to be before I even started. By knowing that I said subtract in the beginning, boom, I already know my next property. It's already in my head because the funnel took me there. If you had to multiply or divide on the first step, which we did not have to do, but if you had to multiply or divide on the first one, this automatically funnels you to the reciprocal property for the next one, because you're going to have to multiply or divide and it makes 1. Okay, so now we have that. Now notice on the other side, I haven't even done that side yet. 22 minus 8. A lot of people always try to jump, and they're like, oh, it's 14. No, wait. Okay, questions so far? Now that we have that, now we can add the 0. So what's x plus 0? X. That's where you're adding the 0. Now, this is now the identity property, because we've already passed the inverse. The inverse is one of these two. That's your inverse properties, right? The inverses. These are the properties of equality. So now, when you're going down the next step, when you get into your identity, since you're already on this like plane, this one is pointing at one specific one. The identity you're doing here has to be add identity. If you're on this side of the board, it's the multiplicative or multiplying. Multiplicative identity. Because you're multiplying by 1. But in our case, we had to add 0. Or subtract 0. It's the same thing. Then your last step, easiest thing in the world, it's got to be substitution. So, and that's 14. It should take you 4 lines of work if you have one number to get rid of. So to get rid of the number 8, it took me 4 lines of work. And again, I should probably write my properties down. This is the property of opposites. I already said that. Property of opposites. Because again, I added or subtracted in the beginning. So that kind of fed me down the rabbit hole. So I did the property of opposites. Then I did automatically add identity because I had to add 0. And then I substituted last. Like it's an automatic to me. Like you guys were getting so good at doing like distribution, associative, substitution. Like you guys had those down. The same thing with this. This is what I have, right? This is just, I have those set rules. I don't even have to think about them. I just know what to do because they're always the same. It's rinse and repeat every single time on every single problem. But you have to pick which funnel you're going down, because that leads you to your property names automatically. All right, questions at all about number 1? Okay, here's what I like to do. I'd like you to try number 2 by yourself. I'm going to give you 2 to 3 minutes. Try it out, compare it to your neighbor next to you after you get done. You already know what properties they're going to be because I have the rabbit holes on the board. You know the funnel system. So you got to look at, or not number 2, sorry, number 2. Look at number 3, sorry. Number 3, apologies, number 3. Do number 3 instead, sorry. 3 is a lot easier. It should take you 4 steps. Number 3. Just have the numbers out of order. So you're doing number 3, sorry. It should take you 4 steps and you go down the rabbit hole and you should figure it out. Give me a little bit of time here, get figured out, and then I'll get my next problem set up here. when you get done, I wanna check it, I wanna see how well you did, so raise your hand, okay? Got a couple, I just wanna kinda walk around the room, see how you did. Boom. Go ahead first. The only thing I want to change is multiple deadbeat.
Oh,
Good, nice.
I'm definitely wrong then.
Huh?
I'm definitely wrong then.
Did you got a different answer?
Yeah.
Yeah, definitely not.
I know.
Um, Division. Okay, all right. Before you go on, what's the first property? Division. You're not adding or subtracting on this one. So double check your paper. Here's the reason why, number 3. What are they doing between the 3 and the W?
Timesing.
Multiplying, so you have to divide. So that sends you down a certain rabbit hole now that you know you have to divide by 3, not add. It's a common mistake, don't get me wrong. A lot of people make it because they see the negative, like, oh, gotta add. Add can multiply, you gotta do the opposites. All right, so that fixes your problem. Do it, because I want to double check yours here in a minute. So if I haven't checked your work, keep going. I checked, I think, 1, 2, 3, 4, 5. Okay. Double check, make sure you get your properties. You know which route you have to go down. Just make sure you have all the property names written. Answer for the question. Just add the 0 there. Should be easier. That was the first one. Oh, you did that, and you were like cruising right in here. It's like, so. Anyone else want me to double check? Good. Yeah, you didn't even have to divide by 1, the math is correct. Multiple good, that's how you where you come from. Not property the opposite. Because you're on a different track. Yeah. Divided. Okay, division property divided, reciprocal. What's -3 divided by 3? 1, so put 1W. And now you get rid, now you multiply them once, you just put W. And then the next step, what's 18 divided by 3? 6, so put W equals 6. And there's your problem. So you did, I think, reciprocal, right? Right? Yeah. Okay. Anyone else have to check? I think I got everyone, didn't I? Okay, good. All right, so you guys see it? You're doing division property. So now that you know it's division property equality, here's your list now. Because they went down that one specific rabbit hole where you're going dividing property equality, because I know how to divide, that's a common mistake, don't get me wrong, a lot of people make that mistake. So you divide first, so it's division property equality, prop of EQ, of equality. Then you're going to get a 1 on this side, and that's why you're taking a different property name. Because to make 1, you know, -3 divided by 3 is 1, it's not zeros. So you're not doing property of opposites. You have to do the reciprocal rule. That's when you divide and make 1. Reciprocal. then when you multiply the 1, that's identity. Now I know some people were putting division identity because they knew it had to be the division part of it, but it's actually identity. I was looking for, did you at least have or division identity? But it's called a multiplicative identity. That's the correct term for it. And then the last step, when you take 18 divided by negative 18 divided by negative 3, you should get 6. Now the big thing, and that's substitution, but the big thing I want to make sure you're not putting zeros in here, because when you divide 3 by 3, you don't get 0, you get 1. Make sure of that. And the other thing is, check your final answer, see if it's positive 6. So do that right now, double check. Is it positive 6? Because another thing that people forget is they forget to cancel the negative signs out. So the negative signs top and bottom will cancel. So it's just a little rule. Alright, but pretty good. It looked like everyone had the right idea. Once you do kind of which spot to go down, hopefully this little chart makes sense to you. Okay? This is something that I have visually kind of in my head, how I know which route to go. It's automatic. When I first start the problem, I know instantly which route I'm going when I first start. I'm going this route or that route. Okay, so that makes sense. Now, 2 and 4 we're going to do on Monday. Because 2 and 4 are completely different animals. Those problems will require that you have multiple sets. So we're going to have a lot of different things we're going to have to do. We might actually have to transfer these to the back of the page. Okay, have that little worksheet, put it away. You need that for Monday. Monday should be the last day where we have that thing all the way filled out. So again, we should have 1, 2, 3, and now 1 and 3 on this bottom part. Okay? Alright, let's move on. Okay, today. Let's see, here's this. Boom, we have 3 problems I'd like to look at today. These 3. Now, what we're doing with these 3 today, we're going to review the properties that we did earlier this week, where it was postulate 2.1 to 2.7 and theorem 2.1. Because I warned you yesterday, we had homework today. You needed some form of a textbook, and you're thinking, okay, what are we doing for homework? Because we've been doing a lot of algebra. We're trying to review algebra each day because we're going to have to use that eventually. But I want you to recall those theorems and those postulates, right? So that's why I've been going back and forth constantly this week, because it's supposed to build up memory if you keep recalling what you've done previously. So hopefully this will make sense to you. All right, so if you have your notes or some form, I want you to have those notes that we did earlier this week about all 7 of those postulates. Okay, what I'm going to do is I'm going to put a question on the board about this picture or the other pictures, and I want you to figure out which postulate out of the 7 it deals with. Does that make sense? Okay. So let me start this up the camera so we get the whole thing on film here. Okay, so we have my picture. There it is. First thing. So here's my first statement, and I want to know which postulate it is. Line PQ intersects line RS. So out of the 7 postulates we have, one of them talked about this. Hey, Asia, what do you got?
2.6.
2.6. All right, can you say it? Do you have that in front of you? Can you read it out loud if you want? If you wish.
If 2 lines intersect, then the intersection is exactly 1 point.
1 point. Boom. You're seeing it right there. The 2 lines intersect at exactly 1 point. Let's call this point X. Now, when you name it, right? That's postulate 2.6. That intersection point. When you name it, you say point X or whatever it is. You actually have to write the word point and then whatever letter comes after it. Does that make sense how that postulate works? We had to do that in the first chapter test, but now you have to know the postulate that allows you to do that. So it's postulate 2.6. Okay? Okay, next one. Points R and S are connected by one line. So this is my next example. So out of the 7 postulates, there was one that said it. Okay? You got it?
2.1.
2.1. All right, good. So postulate 2.1. 2.1, can you read it off? Do you have it in front of you?
Through any 2 points, there is exactly one line.
So connected by one line, exactly one. So that's 2.1. And again, what I need you to know is the postulate number, know what it says, you know, it's connected by one line. But notice, we're starting with the points and we're finishing with the line. That's a big deal because there's another postulate later that went backwards from there. Okay, so that's points R and S connected by one line. That was postulate 2.1. Last thing. Now this is not a postulate number 1. This is not like, what postulate number is this? This is a sometimes, always, or never question. So, in fact, I'm going to write that up there. This is a sometimes, always, or never question. Now, before you like fire your hand up and like, what's this? I want you to think about it for 2 seconds, because I might be trying to trick you. Let's see. All right. Line. All this will help me out with the names. Line L contains only point P. So line L contains one point, it's point P. So sometimes, always, or never. It's a kind of a tricky question because every instinct in your body's like, oh God, which one is it? Contains only one point P. All right. You're like, what?
Never.
Never. Okay. Why?
Because a line has to contain 2 or more points.
Oh, nailed it. Nailed it. Right? Every line has to have 2 points. 2. There's P there, but you also see what's the other point down the road?
Q.
Q. You knew it, right? So this is a never. I know this is the hardest thing to say. Like you're thinking, wait, you just told me never? It doesn't just contain 1 point, it has 2, word for word. That was perfect. All right, so that's the idea. Now that object there, that postulate, if you want to know, is postulate 2.3. That if you start with a line, it contains at least 2 points. At minimum 2 points. That was really good. So at minimum 2 points, but that's the postulate. But again, that's a never question. Because it was asking, it only has 1 point on it, point D. It has to have 2. Okay, so that's why in your book, you can now add extra points to a drawing. So if you're going to do that, you have to draw it in your paper. So don't draw it in my book. All right, but that's sometimes, always, or never. We'll come back to that type of question here in a minute. In fact, yeah, we'll come back. All right, next picture. So now this is going to test your vocab on your postulate numbers again. Question number 2. Okay. This line K is poking through the paper. So it went dash. It's like poking through like a pencil. So, all right. So here's my example. I want to know what postulate number says this. Line J is contained on plane, what is this one called? Plane M. Okay, we got 2. George?
Postulate 2.5.
Postulate 2.5. All right, can you read it off for me?
If 2 points lie in the same plane, then the entire line is in the plane.
Good. We have a line that's on a plane. That line is on that plane. It's when you can draw a line that's actually on a plane for the first time, it's allowed. So that means that knowing that line is on the plane, it also has the points that are on the plane as well. So I can put other points here. And Now, which postulate allows me to draw A and B like that? Which postulate allowed me to add points A and B?
Postulate 2.4.
Plus.
2.1?
2.3.
2.3. Is the one you said earlier. 2.3. 2.3 was when you can put multiple points on a line. So I can put that on there. 2.4 though, she is somewhat correct because 2.4, you can put points on a plane. So she is somewhat correct. I know it's hard, but if I want to put them on the line, it's 2.3. If I want to put them on the plane, like I'm doing here, now we're in the realm of 2.4. So you're that figured out. All right. Does that make sense? Do we get a sense for how this works? All right. Now, let's get to the plane question. Yeah, plane. The X and Y are the names of the planes top and bottom. We have the green planes. If you're colorblind, starts at the top and bottom of the sandwich. Okay, so here's the question. I want to know what postulate number it is one more time. Points E, A, and B are contained on one plane. Okay?
Postulate 2.1.
Oh.
2.2.
2.2. Aha, I was talking. Aha, yeah, because 2.2 and 2.4 almost have the exact same wording. It's 2.2. Here's why. Postulate 2.2. I know. It's like, God, which one is it? Okay, 2.2. I start with the points. I have the points. I'm going to draw the plane second. Agreed? 2.4, you have the plane, and you're going to draw points on it later. So I started with the points, and now I'm drawing the plane that can contain them. So it's kind of a weird play of words, I know. It's frustrating because 2.4 and 2.2 are so similar. But if you start with the points and you end with the plane, that's 2.2. But if you start with plane and there's points on it, then that'd be 2.4. There's such similar wording, it's frustrating. Okay, now, here's my question. This is a sometimes, always, or never question. Sometimes, always, or never. Two planes intersect to form a line. So, before you answer, this is a sometimes, always, or never question. Okay, we're starting to figure some of these out. Okay, you can put your hands in, I'll call it one of you here in a second. Just think about that, just for a second. Two planes intersect to form a line. Sometimes, always, or never. Sometimes, always, or never. Alright. Got it in your head? Alright, so I'll just pick at random that.
It's postulate 2.7, so it's always.
Always, 2.7. Okay, 2.7, two planes intersect to form a line. It's always, because we have a postulate, so that's duh. So it's postulate 2.7. Okay, 2.7. So that allowed me to say always. Now, question?
Okay, so not always do two planes intersect, so how does that work?
If they intersect, they have to form a line. If they intersect. But if they don't intersect, that's a different question.
Shouldn't it be sometimes?
I'm saying that they're intersecting.
Oh.
I'm saying this. If I said just two planes don't intersect, then you would have parallel. So if they intersect, do they form that? Yes, they would. Okay, I see what you're saying. I'll get to that question here in a second, so everyone will understand. So I can word the question differently to get to what you're asking. Okay. All right. We'll get to what we were saying. She has a really good idea. That's what she's talking about. Okay. All right. Three planes. If they're intersecting, mind you. So that's to answer your question. So if these planes are actually touching, Three planes intersect to form a line. True, like sometimes, always, or never, that type of thing. Bree, what do you got?
Sometimes because they probably aren't touching the exact same place.
Okay, so sometimes, and I agree with exactly what you said, sometimes they don't be having to pass through the exact same spot. Let me show you a couple pictures. Okay? Alright, let me show you a picture here. I have a couple different pictures that I think will fit the mold for what we need. Okay? Alright, and this is the most challenging part of this next part, is this one right here. Alright, here we go. Alright. Alright, here we go. Here's the first one. They could sometimes do this, where you have three planes crossing all at once. It's kind of like a Rolodex. If you've ever seen those old school Rolodex with like the telephone, like numbers on them, like the secretary says you have them on their desk. You can use them for note cards. Very similar to how a spiral notebook works. It's very similar, like you could have multiple planes kind of interacting, and then that line right in the middle is the actual wire. Like there's a line of wire there where they're all touching different planes. It's really hard to hold this, but different planes. So you could have that, but she said sometimes, right? So Bree is correct, because it doesn't have to be just this picture. They could be crossing at one point where you have different planes at different levels. So it would be like, for instance, it would be the corner of my room, the dot in the corner, where you have where the ceiling and then the two walls meet. There's a dot right there, right where that corner meets, and you can actually see it's like a perfect dot in the corner. Okay. It's in the corners of the rooms as well. But yeah, so one specific dot. Or, and notice this is three-dimensional, so it has three actual coordinates. We've never seen that before. It has three coordinates. And then this is the other one that she was kind of hinting at. They don't all have to meet at the same spot. So they could make lines, and there would be three different planes crossing at different modes. That's when you're trying to make like a house of cards kind of idea, and you're trying to stack them. It's that same situation. You're trying to make the best form that you can. Now, let me change the wording of this problem now. I'm going to go back to what Wheeler was talking about earlier. Two planes form a line. Now, I didn't put the word intersect, so that throws that out the window. Do two planes form a line? Yes, they could. They could. Two planes could form a line. They could, mind you, that wording, because of what Jacob said earlier, it said 2.7, so that's sometimes. But do they always have to form a line? No. And this is what Wheeler was talking about. What if I went back to, actually, let's go back to that original picture I had. Let me go back to that original picture. I don't know if I have it here. Let's see, do I have it? Might be just here. This one. This is why I put this picture up here earlier. And this is what I think you were hinting at. What if they're parallel? Now they don't have to form a line. But if it says they intersect, then yeah, they have to form a line, because that was a postulate. But if I just say they have to form a line, that's not always true. Because I could have parallel lines, so that's sometimes true. It's the weird play of words that happens here. All right, here's your homework today. This homework will be due on Tuesday, this coming week, Tuesday. I'm gonna put it right in the middle of the board here so you have it, and I'll put it on the board over there. Okay, page 130. This is the easiest homework assignment in the world. All you have to do is tell me the postulate number, like we were doing in class, and then I think there's like 4 or 5 questions that say sometimes, always, or never true. So, page 130, numbers 1 through 6. That's the first one. They're going to give you a picture. They're going to ask you what postulate numbers. Then you're going to do 7 through 9. This is a sometimes, always, or never problems. You have to look at their own picture. Tell me sometimes, always, or never. Then we have 10 through 13. That will be a different picture. I think it's back to the postulates again. I think it's 3-dimensional. Next one, 16 through 21. This is another problem where they ask for what postulates. They go to 3-dimensional again. I think this one, 16 through 21, I think they have like a cake, like a wedding cake. They have like lines drawn on it everywhere. And then 24 through 28 are the sometimes, always, or never questions again. It should be the shortest assignment you've ever done, because it's super quick if you know your select few postulates. This is due Tuesday. Not bad, not bad. Yeah, play of words really gets people on this list. So be careful when sometimes, always, or never stuff today. The wording could be deceiving. Okay, so there you go. Set the camera. The rest of the time is yours. You have about 4 or 5 minutes here. I'm going to go through the list of people that still owe me stuff here in a second, because it's due today.